So we're going to be talking about factoring special cases. I want to start with the pattern. We're going to talk a little bit about greatest common factor, and we're going to go from there. So I just want to show you, so I have two terms. One is minus, so this is the sum and difference. So this is 7k minus 4 and 7k plus 4. So you have the same two terms. If I actually multiply that out, 7k times 7k is 49k squared. 7k times 4 is 28k. Negative 4 times 7 is negative 28k. Negative 4 times 4 is negative 16. I notice that these are the same, and they add to be 0, and so I have 49k squared minus 16. Okay, if I multiply that out. Next one, just really quickly, I'll do a box method. For those of you that do the box method, I have 6x, 9y, 6x minus 9y. That's going to be 36x squared minus 54xy. This is positive 54xy. This is negative 81y squared. And so I notice that these also add to be 0 because I have the same two terms. When I multiply, I have this positive 9 times positive 6 and this positive 6 times this negative 9. And so they cancel, or they add to be 0. And so I end up with 36x squared minus 81y squared. That one was weird. So the other thing I want you to notice is if I take the square root of this, this is going to be 7k, and if I take the square root of this, this is 4. If I take the square root of this part, this is going to be 6x, and I take the square root of this part, this is going to be 9y. And so that's kind of the pattern. So when you're given something, you can actually work backwards. Next thing I want to go over very quickly is greatest common factor. So the greatest common factor, you need to factor it out first. We kind of didn't emphasize that, but now we will. Before you continue to factor, greatest common factor of 12 and 10 is 2. They also both have an a squared. So what I'm going to do is I'm going to factor out, and to factor is to divide. Okay, it's the opposite of multiplication, a 2 and an a squared out of each term. Okay, and that one that I factor out goes on the outside of your parentheses. So I have 2 goes into 12. 6 times. I have 2. When I'm dividing out, it's subtracting, it's taking away. So I have 3 a's total. I take away 2. I have 1 a left. 2 goes into 10 5 times. And then I have 2 a's. I take away 2 a's. I'm just left with just the 5. And so this is your factored form when you're just finding greatest common factor. Same thing here. I have my 14 and my 7. Of course, the greatest common factor of 14 and 7 is 7. I also have 8 m's here and 2 m's here. So what's the greatest number of m's they have in common? They both have 2. And I have an n to the 5th and n squared. The greatest number of n's they have is 2. So I'm going to factor out a 7, an m squared, and an n squared from each of these terms. And so what I'm left with is 2. So I put my 7, m squared, n squared on the outside. 7 goes into 14 2 times. M squared and m to the 8th. Well, I'm dividing out 2m squared, so I'm left with 6 m's. I am taking 2 n squares from n to the 5th, so I'm left with 3 n's. Okay, the 7's divide out to be 1. You can write the 1 if you want. The m's divide out to be 1. And the n squareds divide out to be 1, so I'm just left with 1. In that case. So now we move on to the difference of squares. So that's how to find greatest common factor. That's the first thing that you do. Things to be reminded of, your list of perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169. And of course there's a lot more on top of that, but those are the ones we'll start with. Okay, so when you're given a squared plus b squared, this is called the difference of squares. So it must be subtraction to use this. So that's the first thing. Okay, so it cannot be a squared plus b squared. Okay, it cannot be a squared plus b squared. This will not work with that, okay, because one has to be plus and the other one has to be minus, okay? So the first thing you always do with problems like this is you, of course, factor out the GCF, okay? And then we follow a pattern. So you're given a squared minus b squared. So the first thing that you're going to do is a is going to be the square root of a squared, and b is going to be the square root of b squared. And once you find those, then you're going to rewrite it as a minus b, whatever this is, times a plus b. Okay, that's the shortcut. All right, you just take the square root of each part. To find a and b. So for this one, first thing, I look at 9 and 4, there is no GCF. So the next thing I say is I take a, my a term is going to be the square root of 9a squared, and my b term is going to be the square root of 4. So when I'm talking about a and b and the difference of squares, this is going to be 3a, and b is going to be 2. And so I just write it, my answer is going to be 3a. So the factored form of this is going to be 3a plus 2 times 3a minus 2. And I'm just going to show you really quickly what happens when you multiply those. So if I have 3a plus 2 and 3a minus 2, that's going to be 9a squared minus 6a plus 6a minus 4. These had to be 0, and so I'm left with my original problem, which is 9a squared minus 4. And so that's just simply your check. If you multiply them out, you should end up with the original problem. Example number 2, again, we have no GCF. So to look for my a term, to use the formula, I take the square root of 25u to the 4th, okay, which is going to be 5u. To find my b term, I take the square root of 4v squared, which is going to be 2v. And so I substitute it in. It's going to be 5u minus 2v times 5u plus 2v. And that's it. All right, let's do this one more time with one of these. Again, there is no GCF. My a term is going to be the square root of 9x squared, which is 3x. My b term is going to be the square root of 49y squared, which is equal to 7y. So my factored form is going to be 3x plus 7y times 3x minus 7y. And that's it. That's it. That's your answer. Okay, sometimes it does get a little bit tricky. This one here, again, no GCF. I know a is going to be the square root of m to the 4th, which is going to be m squared. I know that b is going to be the square root of 16, and don't put the negative there. We're just talking about this is your a squared term, this is your b squared term, is equal to 4. So, and these are just positive roots that we're talking about. So I know that my factored form is going to be m squared minus 4 times m squared plus 4. Now, you have to be really careful because when you have something like this where you have a squared, these are both perfect squares. So I can actually take this. This can actually be factored again. And how do you know? Look for perfect squares. So in this case, my a would be the square root of m squared, which is m, and my b term would be the square root of 4, which is 2. So this guy right here, actually, let me get to blue. Okay, when I take this and actually factor it again, okay, that's going to be m minus 2 times m plus 2. And then this one cannot be factored because it's plus. Okay, and so we just leave this as m squared plus 4. All right, so let's just do a few more. So that's your final answer there. Down here, I do find that I do have a GCF. The 72 and the 2 have a GCF of 2. So I divide each part by 2. So that's going to be, I take the 2 and I put it on the outside. Okay, just like I did before. That's going to be 36c to the 4th minus 1. I'll put this over here. I know my a term is going to be the square root of 36c to the 4th, which is 6c squared. And my b term is going to be the square root of 1, which is 1. And so I remember to carry my 2 on the outside. I know it's going to be 6c squared minus 1 times 6c squared plus 1. And here's something that's notable for this. This, you're done because it cannot be factored further. No perfect squares. And so there we go. This next one here, I first look for my GCF. My GCF for 7 and 28 is 7. I look at what else they have. They both have m's. The most number of m's that both of them have is just 1. And they both have n's. Okay, this has got an n and this has got an n cubed. So I'm going to divide each part by 7mn. 7mn. I'm not going to forget to write that. That's still part of my problem, because if I multiply everything out, I should end up with my original problem. The 7's divide out to be 1. Now I have 6 m's, and the n's divided out to be 1. I divide these out. This is going to be 7 goes into 28 4 times. The m's divide out, and I'm left with 2 n's when I divide out the 1 on the bottom. Okay. Now, I know my a is going to be the square root of m to the 6th, which is m cubed, and b is going to be the square root of 4n squared, which is 2n. And so I remember to write my 7mn, and my factored form is going to be m cubed minus 2n. Ooh, that's not good. Minus 2n. And m cubed plus 2n. And there is my final answer. Can't be factored anymore because I don't have any perfect squares, and you only can look at minus. Okay. Moving on to these. Is there a greatest common factor? Yes. They both have 3. So my GCF is equal to 3. They have no variables in common, so all I have to do is divide each of them by 3. I end up with 4x to the 4th minus 25y to the 4th. I factor this further. I know a is going to be the square root of 4x to the 4th, which is 2x squared. And b is going to be the square root of 25y squared, which is 5y. And so my factored form, I remember to bring my greatest common factor just down. You don't have to do anything with it, you just have to bring it down. And it's going to be 2x squared minus 5y times 2x squared plus 5y. And it doesn't matter what you have first, if it's the minus or the plus first. You just need to make sure that one is minus and the other one is plus. On to the next one. I see that the greatest common factor for both of these is 10. And they both have a w, so I divide each part out by 10w. So when I divide out by a 10w, I end up with the 10's divide out to be 1. I'm left with 4 w's. These 10's divide out to be 1. I think I can factor this further. I can take the square root of my first term, which is going to be w squared, and I can take the square root of 1, which is just 1. So I bring my greatest common factor down. That's going to be w squared plus 1 times w squared minus 1. Now I look, you need to remember that 1 is a perfect square, okay? Is w squared a perfect square? Well, yes, both of them are perfect squares, and this is a plus. This cannot be factored further because even though they're perfect squares, this has a plus. Okay, so I know this can be factored further, so I know that a is going to be the square root of w squared, which is w, and b is the square root of 1, which is 1. So I know that this one right here can be factored to be W minus 1 times W plus 1. And so my final answer, I bring these two parts down, okay, because I couldn't do anything more with them. I'm also going to have a